Hi, welcome to the video number 3 of the lecture number 6 of the process mining course. In this video, I'm gonna cover the workload demand and the demand analysis, the rework analysis, and the overprocessing analysis. The workload analysis is measures how busy are we and why. We can do that using the frequency of the resources. Mainly, we will define the overused and the underused resources. We can get that from the process discovery. After that, we switch to the resource perspective, and the frequency attached with every resource represents the number of cases that the resource executes. If the number of cases is high, that's an overused resource, and if it's very low, it's an underused resource. Here, I would like to mention that we are measuring this workload analysis from the perspective of the process. However, some resources can be included into more than one task, into more than one business process, into some other tasks inside the organization. So it's better to combine the workload analysis from the perspective of the process with other workload analysis inside the organization. Another way of getting the workload distribution is through the dashboard using this total frequency of cases, which is a pie chart that is supported inside the Promore. We can visualize it using the pie chart or the bar chart as here. Here you can see that there are some resources that are overused and there are some resources that are underused because of the frequency of the events they execute inside the organization. The demand analysis or the work in progress analysis is where we focus on how much work in progress that we have. Basically, we can use the demand analysis in order to compare the behavior inside the business process with the existence of a peak season that we have a lot of requests inside the organization and a very not busy season that we have rare cases or very fewer cases than the season. We can do the demand analysis using filtration, so you can filter the cases that belongs to this high demand season and filter the cases that belong to low demand season and compare the behavior of two cases together. Let's take an example. First, we have this event log, which represents a procure to pay business process. The first thing we need to switch to the resource perspective in order to define the overused resources and the underused resources. This event log contains 600 cases. There are some resources like Carol, like Francois, like Magdalena. They execute more cases than all the other cases. Like Magdalena executes almost 2/3 of the cases inside the event log. Francois is the same, and Carol is the same. So these three resources that we have here, Francois, Carol, and Magdalena, they can represent overused resources. On the other hand, the underused resources are resources that execute very rare cases. Like for example, here we have Anne executes 160 cases. We have Hiyu executes 166 cases. Kim is the same, so we have now defined the overused resources and the underused resources. For the same event log, I want to compare between the behavior inside the event log with high demand versus with low demand. I'm gonna make a filter. That filter, I will filter the cases that has occurred within a high demand season, like here, like this period. Here to there. This is a high demand period. So I'm going to filter the cases that exist here, and I'm going to filter the cases that exist in this low demand period, and I'm going to compare the behavior between both of them. Now I will save this event log to be procure to pay high demand, and I will remove all the filters and I will redo the filter again, but for the time frame with low demand, like here. Then I'm gonna export the event log, so it's low demand. And now we have both the event logs here. I can just visualize them together using the dashboard. I can bring the relative cases. So from this dashboard, we can see that for low demand, on average, the case duration takes shorter than the average case duration with high demand, which is being expected because we have more cases to execute, so we will have more waiting time. The third type of the performance mining analysis is the rework analysis, where we detect the activities that we repeat and why we repeat them. We can do that first using the discover itself by discovering the loops. There are some loops that, like this loop, is a self loop between for the activity itself. There is a short loop between two activities, and there is this long loop here. That's three types of rework inside the organization. We can either trace them using the process map as shown here, or we can make filters in order to filter them by the repetition. Detect the loops or the rework from the process map via detecting the loops inside the process map, or we can bring the maximum frequency for every activity that will show the maximum frequency of every activity per case, and that's the number of repetition execution for every activity inside the case. Like here, for example, the repair complex at maximum has been executed 4 times in a case. That's a repetition, that's a rework. The test repair also has been executed 4 times for the case, which is a repetition. The restart repair has been re-executed 3 times in a case, because we have shown the maximum frequency. Also, we can bring the maximum frequency per case distribution from the dashboard inside the Promore, and that will bring us the activities that are being executed more than once for every case, and that's the rework that we can detect from this dashboard. As an example to discover the rework inside an event log, this is the repair example event log, the same as in the slides. I'm gonna switch to the maximum perspective, the maximum aggregation, and the maximum aggregation shows that there is the repair complex can be repeated, the test repair can be repeated, and the restart repair can be repeated, because I've shown the maximum frequency per case. So that's the first way of detecting that. The second way is via filtering. So I'm going to bring the filter, and there is a rework filter. The rework filter, I can just order by the maximum, and I can bring the repair complex that occurs more than 1 time. This is more than 1 time. And now I have the cases. So I can just bring the average, and also I can show the cases that there is a repetition. Then you can trace every case separately. You can get the IDs here. So as you can see, the repair complex has been executed 1, 2, 3 times inside the same case, and that's a rework. So you can visualize the rework through the maximum aggregation, the filtration, or the dashboard. The fourth analysis for the process performance mining, which is the over-processing analysis, where we find the activities that we execute and we should not execute these activities. For example, in this process execution, we have some cases that they exit the flow before getting accepted, so they just get rejected earlier. So the amount of work that we perform at the beginning of the case for the cases that are rejected, we have already wasted them, because we have put some effort and we have executed some activities for those rejected cases, and they are just going to be rejected. The earlier we can perform this rejection, the less waste we will have. Let's have an example about that. So this is a procure to pay business process. We have some cases that they exit the flow from the analyze request quotation. So they exit here and then they go to the end of the case. So now I have the cases that only have, they don't have this exit. I can just go to the filter and I can reverse the filter. So I will return only these cases that they end earlier. So these cases, for these cases that they exit later, they exit earlier from the process, I execute create purchase requisition, analyze purchase requisition, amend the purchase requisition, and all the other activities. They represent 21% of the cases. In order to calculate this waste cost, you can calculate the duration of every activity and multiply that by the cost for every activity. Then you will have the cost of waste, because just some you execute a lot of activities for cases that are getting rejected from the process. Summary for the performance mining analysis, we have this template here. On the left hand side you have what type of the analysis you can perform, and on the right hand side you can see how to perform that. For the process analysis, we have discovered the bottlenecks, the workload, the rework, or the overprocessing. Also, it's a good practice to show the difference between the process with the existence of the bottlenecks or the workload and the process without that workload. So you filter the cases that they have this bottleneck there, and they keep the cases that are not with bottlenecks, and you compare the performance between both of them. As we have explained already in the previous lecture, the variant analysis can be done. For that, you can use this template for performing variant analysis after doing the performance mining. In the next lecture, I'm going to explain what if scenarios, or what we mean a simulation for the business process. See you in the next lecture.